Unit 5c.3, which is joining metals. Your objectives are going to be to know that metals can be joined in permanent and non-permanent ways, be aware of the various methods that are used to join different types of metal, understand the limitations of different metal joining methods. Grades 1, 2 and 3 you'll be able to identify and categorise the basic metal joining methods. 4, 5 and 6 you'll be able to describe the positives and negatives when joining metals. 7, 8 and 9 explain how to create metal-based product using the appropriate tools and equipment. So, specialist tools and equipment. The most common way that you're going to be able to join metal to itself or any other metal is to use heat. So these methods are usually going to be permanent and you can't undo them, which means that recycling, if you're using two different types of metal, is going to be a little bit more tricky. An alternative to this is going to be the non-permanent method, so you're going to be using some kind of mechanical advantage to hold the materials together. So think riveting and nuts and bolts. It's going to allow for the products to be taken apart for maybe transport or even repair. Okay, these are going to be the methods that you're more than likely to be able to do at home or in school. What you're going to need to do is complete the missing information on the resource sheet on the right hand side. If you listen to the video tutorial and then fill it in at the end, see what you can remember, what can you work out, and then possibly go back through the video again just to fill in any of the blanks. For each of the boxes in the grid, you're going to need to give me the name of the different type of joining method for the semi-permanent and the permanent fixings, and then you're also going to need to be able to draw me a quick sketch in the box as well. So, first one. This is soldering, otherwise known as soft soldering, and generally speaking this is to attach components onto a PCB or a printed circuit board. Effectively, you're going to use a soldering iron. Soldering iron's tip is going to heat up to around about 400 degrees, and what you tend to do is heat the metal inlay onto the circuit board, and you're going to heat the actual component itself. So you're going to be applying heat to the circuit board itself and then the component leg that's coming through. Once they're hot enough, they're going to take the solder, which you apply afterwards, and the solder is going to be a metal with a slightly lower melting point. You're going to put that onto the tip, and it's going to be hot enough to melt the solder, and it's going to be hot enough on the components for it to stick together. It allows the circuit to be complete, to allow the current to pass through, and effectively creating your working electrical product. Positives to this, you're going to use it for light electrical connections and also plumbing joints. So think about if you've got any metal plumbing pipes at home, things like copper piping for radiators and water, all the different joints that are joined together on those, they're going to use solder. Heats it up and then seals the joint, meaning that it's going to be water resistant. It's cheap, it's school friendly, it means that we can use it quite easily in a school situation. The negatives though are if the PCB or the circuit board has extreme heat applied to it, then it can actually fail. So what can happen is the little soldered joint can effectively come apart, and then you'll end up having a failed joint. The electric doesn't work anymore. And too much heat can blow the components, so the components such as LEDs can get blown out if you apply too much heat to them in the first place. As well as soft soldering, we've got hard soldering. This is otherwise known as brazing. Similar sort of process, we're going to be heating up two pieces that are going to be joined together and then apply a slightly different metal that goes in between them. In this case, this is going to be used more for heavy applications. So think about having two pieces of steel and we're going to join them together. Joining those two pieces of steel, first of all, we have to heat it. We're going to use probably a gas torch on the brazing hearth, and it's going to heat the metal up so that the metal isn't going to melt, but it's just going to be warm enough so that it's going to allow the filler rod, and in this case the filler rod is going to be a brazing rod, which is the copper and zinc alloy. That's going to go in between. That one will melt and it'll stick to the two pieces of steel. When it cools down, you quench it, so that means popping it into some kind of fluid bath. When it's cool, the copper filler rod will be set and it will be stuck to, acting a bit like a glue and adhesive in between the two different steel layers. Positive to this, you can use it for heavy applications because the joint's going to be a lot stronger, so we can actually make things out of it, so you can make physical objects and actually braze them together. It's school friendly and it's cheap, so we can do that in school nice and easy. The negatives are that the steel has to be heated correctly, so you have to get the steel pieces to the right temperature before they'll allow the copper rod to stick to them. And the only problem is the joint is always going to be weaker than the actual metal itself. So it's going to fail on the joint. Gas welding. So welding, how does that differ from brazing? The way it differs is with brazing, you're only heating up the two parts of metal. With gas welding and any kind of welding, you're going to effectively be heating them up to the point where they will actually melt. So as you can see there, you've got your two different pieces of metal. So you've got piece 1 and piece 2, and you're going to use a gas torch. It's going to be a mixture of acetylene gas and oxygen, and it's going to produce a very small hot flame, so 3,500 degrees, and you're going to apply that to both the pieces of metal. Both those pieces of metal are then going to get so hot that the two surfaces are going to start to melt. Now, as you can see, there's an area in between which you're going to need some extra material to fill it, which is where the actual welding rod will come in. So it's going to be a metal of the exact same material. So if you're using steel on piece 1 and 2, then the welding rod that comes in, that will also need to be steel as well. And the idea is you work it in a left and right sort of phase, or you can be going in circular motion, and that's going to fill in the gap as you work your way along. Positives to this, we're going to have extremely strong joints. It's going to allow very large sections to be joined together. So think about the welding together of things like JCBs and diggers and things like that. And it does create a sealed joint, so it means it can be used to contain things in, so fluids and things like that. The negatives are it can be very dangerous because of the gas that's going to be in use. Equipment and training, you're going to need them, and it's going to be expensive in order to do it. For you to become, I suppose, a high quality welder, then you're going to need a lot of time and practice as well. Different type of welding here. This is called MIG welding, which is metal inert gas, and this is otherwise known as electric arc welding. So the idea here is you're going to have it so that electricity is creating the heat rather than using the acetylene gas and oxygen. You're still going to have a welding torch, and that welding torch is going to allow the metal, the actual welding wire, to flow through it. So it doesn't use a welding rod anymore. It's going to have welding wire which is collected up through the system. It's then going to come through the actual torch itself, down through the head, and then comes out at the end. And as it comes out at the end, then what's going to happen is there's going to be an electric spark, and that electric spark is going to go onto the actual metal that you're going to be joining. So you're going to have a really bright, intense spark, and that's going to melt the surface of the metal, as well as feed out this welding wire. So it's going to be melting it and feeding the wire into it, which will then in turn melt as well, and that's how you're going to get your join. Okay. Now, the area then gets cooled with a little bit of argon or CO2 gas mix. This is included actually in the wire itself as it comes out, and that will cool it down. Positives for this, you're going to have suitable for a production line. So think about a continuous production line. Think about those flexible manufacturing systems, the big robotic arms. They're going to be able to come in, they're going to be able to do this task, okay, as long as you've got the program set up. This is school friendly, it's fairly cheap, and it creates a really strong joint. The negatives for this, the spark is really bright, it's very intense, it can blind you, so you will need welding masks on to make sure that that's not going to happen. And then the technique is quite hard to master with this method. Last one here, we've got spot welding. So for spot welding, this is a very similar method to the previous one. The only difference is we're not using any filler rod. We're going to have two pieces of metal which are going to effectively be touching. So think about thin sheet metals clamped together, and then you've got these two pincers, and these two pincers, you're going to have it so that electricity is going to be applied, and they're going to pass between these two areas. So if you've got the electricity that's being applied and getting passed between them, then you're going to have the spark of electricity going in between. That electrical current going in between is going to generate an area of extreme heat in the two pieces of sheet metal. One quick sort of pulse of electricity going through is enough to melt the metal which is on the inside, and then it'll join together. Okay, spot welding it. Positives, it's fast, it's effective, used for things like car bodies, so you can weld really thin sheets together, and you don't have to do a full seam, you can just do small little pinches of weld. And it's good for robotic production lines, so they can do quick welds as they go along. The negatives, the small school machines can only do really thin sections of metal, and if you want a larger machine, then it's going to cost a heck of a lot of money to do it. You can use wheels, so it says there that wheels can be used to create a seam weld. Effectively, it's the same process, apart from there's a metal wheel that runs along the two sides of the thin material, and then it's going to allow the electric current to go between those. Now, Thinking about maybe non-permanent methods, this is talking about the pitch and the diameter. So as you can see on there, we've got a nut and we've got a bolt. So in terms of nuts and bolts, then we need to think about the thread. So the thread is the winding thing that goes around. The pitch refers to the coarseness of the thread, so how coarse it's actually going to be, and how fine the pitch should be depends on the application. So standard nuts and threaded rods are available in various different pitches and diameters. So you've got to think about, if you need a really fine thread, why would you need it? Why do you think it's generally stronger to have a fine or a coarse thread? Which one is it going to be? Now, these metal fixings and components, think about machine screws, nuts, bolts, washers, loads of different diameters, lengths, pitches, different driving methods, so in terms of different heads. So you can see on the sheet there, we've got the flat heads. On some of these you would have cross heads. We've got one here with what we use in a hex head, which would be with an Allen key, an Allen bolt. And think about the different nuts that have got different functions. So you can see various different things on here, different things. This one here is a cup, so you can screw into something or bolt into it and you can have it so there's a nice surface. You're going to have maybe washers on there, you can see a spanner, things that are going to be used to drive these nuts and bolts on. It says here, suggest one application where a wing nut would be most suitable. So think about a wing nut and think about why you'd use it. If you're not sure about what a wing nut is, then you're going to have a standard nut. Apart from on the top of it, you're going to have two wings which will enable you to then twist it. So think about what application it might be useful to be able to twist with a wing nut. Now, nuts and bolts. This is a mechanical joining method that's got the advantage of being able to join dissimilar materials, so copper, steel, plastics, whatever you want you can add to it. It also allows them to be able to be disassembled. Many different types of these nuts are available for different jobs. So think about the wing nuts for easy undoing, lock nuts that make it more of a permanent joint, more difficult to undo, and also it won't undo itself with any kind of rattling or movement. Hex nuts that use a spanner to tighten. Think about bolts using a spanner, an Allen key or a screwdriver to tighten them in. There's going to be various different methods and each one's going to be more suitable for different jobs. Positives to these are there's loads of different sizes, shapes for nuts and bolts, which means you can have loads of applications. You can make them by hand to fit, and they're cheap and the school friendly. So making them by hand, we're talking about maybe using the threading dies and threading taps. Negatives for this, if you do damage to the thread, which is very easy to do, then effectively you're a little bit stuffed. It's really difficult to then bypass a thread which has then been damaged, because it might just keep spinning. You might never be able to get that nut off there. So the nuts and the bolts both really easy to be corroded. If they're made out of a mild steel, then they can rust, and again, if they rust together tight, you'll be cutting them off. Pot rivets, we talked about these a little bit in last week's lesson. So rivets, they're going to be used to create a semi-permanent fixing between two sheets of metal. So these are pot rivets, okay? Everything that you can see over on this side here, okay? And pot rivets are designed to go in this pot rivet gun that you can see. You're going to have two sheets of metal, so we've got number 1 and we've got number 2. And the idea is we would drill a hole that goes all the way through the metal. That hole is going to be drilled through and it's going to be the diameter of bottom end of the rivet. So let's say you're going to be doing it as a 3.2mm hole. You'll insert the rivet through. This is the direction that it'll have to be inserted, so you have the long stem part of the rivet goes inside the gun. It then gets pushed down and it has to be pushed down completely flush with the surface. As you then start squeezing the trigger and pumping the trigger on the pot rivet gun, what's going to happen is this small head here connected to the long stem, that's going to start to pull upwards, and as it pulls upwards, the outer sheath, which is made out of a lot weaker metal, will start to split. As it starts to split, then it's obviously going to become a lot wider than the original hole that you drilled, and it's going to mean that it makes it so it's going to be a tight fit. It can no longer pass back out and return the two pieces of metal and get them apart. Once you get it so that effectively this stem has been taken as far as it can go all the way up and it's nice and tight, then the pot rivet gun is going to cut it off with some small guillotines on the inside, and effectively the small stem bit will come away and you don't need that, and then you've got your rivet which is fastening between the two pieces. You do get cold form rivets. So cold form rivets, the original type of rivet. Okay, this is the cold form rivet here, this grey thing. And the idea being that that'll go between the two pieces of sheet metal. So it's going to go through the hole. You're then going to have this snap, and this thing is going to sit over the top, and it's going to position itself over the top of the rivet. You'll then put one on the bottom, and as you put it on the bottom, you're going to apply pressure, whether that be with a hammer or a press. And as you apply pressure and it gets forced on both sides, forcing together, then this area here is going to get so stressed that it's going to dome off. And as it domes off, you can see obviously that rivet isn't going to be able to pass back out either through the top or through the bottom. So riveting. Traditional method is going to be to hammer the blank end of the rivet to form a second swelled head, developing in like the boat building industry. The more modern method uses the gun, so the rivet gun, to fasten the sheet material together. Positives: fast method requiring very little skill. You only need to access one side of the material for it to work, and then it's cheap and it is quite school friendly. The negatives: it can be very hard to remove and replace the rivets afterwards. You don't get a completely sealed joint, so you can still get water passing in between. And the holes do have to match correctly. So if you've drilled them in separate times and separate locations and then hoping that they come together, that can be a little bit trickier. Okay, your job now is going to be to complete the exam style questions that are on the worksheet. Try and remember, 1 mark for every point you need to make. 2 marks is going to have to be 2 points or 1 point explained. Okay, good luck.